Now I'm going to keep working with the primitive shapes, and I'll start by building this simple Y-shaped charger from the first Skill Builder example file. So I'll do a file new to get an empty scene, and then I'm just going to check the grid setting, and I'll set it to 1000 again so that I have a sense of scale. And I'll use a cylinder for the base and start by snapping it to the grid origin, which is a good place to build geometry as we can take advantage of the symmetry. And then if I scale it, you'll see that it's getting bigger or smaller centered on this green point, which is the pivot point. And I can modify the position of the pivot using the Set Pivot tool, either freely with the mouse button or using snapping to be accurate. And then when I switch to Move, it's the pivot position that will get snapped to the grid origin. And this helps now with the scaling, as the lower surface of the base stays on the ground plane as the cylinder scales and non-P scales around it. And it means I can be lazy, so I can just copy and paste that cylinder. And I already have the pivot in a useful place. So I can just curve snap it onto the base, and then scale a non-P scale to create a column. I'll switch into the side view so that I can see the grids and roughly get the size I want. And there's a neat trick in the 2D views, because when I use scale, if I use the mouse constraint keys, then it switches to non-P scale. And that only works in the 2D views. So I can copy and paste again to create an upper arm, which I can then just position on the top of the column with a curve snap, and then rotate in the Y-axis. And here you can see the advantage of the local axes when I want to shrink the length of the arm with non-P scale. So finally I'll copy another cylinder and curve snap that onto the end, and use that as a cover or a flap for the electric socket by scaling it down to a narrow disc. And then I'll give those just some simple colours, and I'll choose a highlight colour for the flap. Now I can pick these left arm components and mirror them to create a right arm, but I'll need to go into the option window on Edit Duplicate Mirror, as we're not mirroring in the default car line. Instead, we want a mirror plane in Z and Y. So I can choose that and say Go. Now let's have a look at this flap and how it might operate and open. And I can do that with pivot points. So if I set my pivot and curve snap to the end here, then this becomes the hinge point for when I rotate it. So I can simulate how the flap might open. But if I were to leave that and go and do some other work and then come back to it later, then it's quite tricky to get the flap shut again. And normally I'd just rotate it to absolute 0. But in this case it takes us back to the creation position, which isn't what we want. So on this other side I'll show you a different approach that uses grouping. So this original flap has the pivot that I used for scaling. So I'm just going to rename that cylinder in the object lister. And now I can do a strange thing, which is to use grouping on a single object. Because what group does is it creates another node which has its own pivot point, which just defaults to the origin down here. So I can just move that pivot up to the hinge position. And then I can rename that node to, say, cap rotation. As the key thing is that the new node has been created in this position, so that when I rotate it, I can always get it to snap shut by typing absolute 0. But then if I wanted to scale it, I can select it at the cap scaling node, which still has my angled local axes and so scales in the right way. So now I'll use grouping in the more obvious way to create an assembly from these two arms. And again I get a new pivot down at the origin which I can move, keeping it central with my right mouse button. So maybe I want to angle the arms towards the user to make them more accessible, or even have the assemble be able to rotate around to get closer to a car. Now that rotated in a particular way because the rotate tool has the options of rotating around the global axes or around the local ones. And if I switch to that, you can see the local axes displayed. And the rotation works quite differently. And it's quite a good way to display the local axes. So if I now go and pick the cat rotation node, for example, in the object lister, rotate then shows those creation axes that were lined up with the grid. Or if I now select the scaling node, it shows how the local axes have been rotated with the object. So just choose local or global rotate depending on what result you need. So just using very simple primitive shapes, we've quickly explored a design concept for a charging station for our electric car. So have a go at this tutorial, or choose one of the other skill builders to practice working with pivots and grouping.